All right, welcome back. So next thing we're going to talk about, can you identify the degree, leading coefficient, and the end behavior given a graph? Okay, so in order to determine degree, you have to look at your zeros and determine their multiplicity. So in this case, we have 0 here, we have a 0 here, and we have a 0 here. Now remember your multiplicities, there's 3 different types you can have. If it goes straight through like this, that has a multiplicity of 1. If it bounces, that has a multiplicity of 2. And then this one goes straight through again, multiplicity of 1. If you add up all your multiplicities, that tells you degree. 1 plus 2 plus 1, this is a degree 4 function. Next thing, leading coefficient. This is telling me, is it a positive leading coefficient or is it a negative leading coefficient? That's when you have to look at end behavior. So, end behavior, it's going up this way, it's going up this way. If it's going up in both directions, that means your leading coefficient is positive. And then the end behavior is, can you write it the same way we were just doing it in the last video? So as x approaches, that should be negative infinity. As x approaches positive infinity, what are your y values doing? So as it goes to the left, if we look at the left of this graph, your graph is going up. So that's positive infinity. As we go to the right, this graph's going up. That's positive infinity. If you look at this next one, we're going to start the same way. So if we want to find our degree, looking for those zeros and finding their multiplicity. So I have a 0 here, I have a 0 here, I have a 0 here. So at this first one, it comes up and it bounces. That's a multiplicity of 2. This one is the first one that we see. This isn't a 1 or a 2 because it comes up. Remember, it has that pause and then it continues on. That's our multiplicity of 3. And then this last one goes straight through, another multiplicity of 1. Let's add them up. 2 plus 3 plus 1 gives me a degree 6. Leading coefficient, is that going to be positive or negative? We are going down and down. So that means that this is a negative leading coefficient. And then if we want to do our end behavior, it's going to be as x approaches negative infinity, our y value also approaches negative infinity because as we go to the left, we go down. As x approaches positive infinity, our y approaches negative infinity because as we go to the right, it's still going down. Okay, so that's finding those attributes of graphs. The next part is going to kind of be the big part. If you can write the equation, you can pretty much do anything that it asks you for because that means you really understand it in its entirety. So I picked the same graphs from above just so we weren't kind of reworking the same thing over and over again. So if you want to write the equation, all right, you have to start with writing down like the pieces that you know. So what you're going to write is it's going to be y equals, your a value is going to be your actual leading coefficient. Like you know right now if it's positive or negative, but you don't know what the actual value is. And then it's going to be times any of your factors. Whatever your factors are, and those are raised to their multiplicities. So if we go back again, we had a 0 here with a multiplicity of 1, we had a 0 here with a multiplicity of 2, and we had a 0 here with a multiplicity of 1 again. So let's start to write what we have. We have y equals, we don't know our a value. That's always going to be the last thing you're going to figure out, unless it gives you your a value in the problem. And then we're going to write our factors raised to their multiplicity. So if it's at x equals -3, that means my factor is x plus 3. Remember, it's always the opposite. That's raised to the first power. I don't need to put the 1. A 0 at 2, that means I have x minus 2 raised to its multiplicity, which is a 2. Last one, x minus 5 raised to its multiplicity, that's a 1. So that's your basic starting point. Then, to find your a value, you need to plug in a point on there, okay? Don't pick one of these, pick something else that's on there. So like this point right here, that's a great point, the point 0, -2. Just knowing that it goes through that point, we can plug that 0 in for all of our x's. We can plug in that -2 for our y. That's going to help us find our a value. So we're going to say that -2 is equal to a 0 plus 3, 0 minus 2 squared, 0 minus 5. And then you're just breaking it down and solving for a. So 0 plus 3 is 3 times negative 2 squared is positive 4 times negative 5. So this is negative 2 is equal to a. Multiply all these things together. So if you multiply 3 times 4, that's 12, times negative 5 is going to give us negative 60. Then to solve for a, we're going to divide by negative 60, divide by negative 60. Make sure to reduce. That tells us that our a value is 1/30. Now, remember, we said our leading coefficient was going to be positive up here, and we got a positive a value. So that's good. That's what it's supposed to look like. So your final equation, you can write y equals, you can write f of x equals, does not matter, is equal to 1/30. And then you have x plus 3, x minus 2 squared, x minus 5. If they asked for it in standard form, you'd have to multiply out all those factors. I doubt that they would, but if they did, then that would just be multiplying. All right, if we do the next one the same way, we're going to start, it's going to be y equals, we don't know what our a value is, and then we're going to plug in all of these. So we have a 0 at negative 1, so that's going to be x plus 1. That multiplicity is 2. Then we have another 0 right here at positive 2, so that's going to be x minus 2, but that has a multiplicity of 3. And then our final 0 is at 4, so x minus 4, that has a multiplicity of 1. So we're just going to get to leave it as is. Again, pick a good point on there. The y-intercept's always a nice easy point, so that's why I like to use that one, because then 0 is obviously really easy to plug in. So here you're going to do negative 4 is equal to your a value, and then it's going to be 0 plus 1 squared, 0 minus 2 cubed, 0 minus 4. Start to simplify. 1 squared is just going to be 1. Negative 2 cubed, so negative 2 times negative 2 times negative 2 is negative 8. 0 minus 4 is negative 4. So this is negative 4 is equal to a times 32. Divide by 32, divide by 32. You're going to get that a is equal to negative 1/8. Again, if we go up and look, we said that our leading coefficient should be negative. It is negative. That's always a great check. So your final answer, f of x or y is equal to negative 1/8 x plus 1 squared, x minus 2 cubed, x minus 4. Again, if it wants standard form, that would mean you have to multiply it out. Again, I don't see them asking you to do that on a time test. All right, tune in for the next page if you need a little bit more help on that one too.